Can anybody see my screen?
Yes.
Okay. Great. So we start with it's actually much. Oh, lab 3 is this calculation. I thought it's actually lab 4. Oh, interesting. Okay. So let's just start. Right, to compute the area of any circle and use this method to display the result. In the lecture, there is an example on how to create your own method to compute the circumference of a circle. Okay, so basically, the whole idea of lab 3 is methods. So before I go into the lab, I'll just take a brief moment to explain what a method is. He explained yesterday also. I'll just take it again for any case. Okay, yeah. So method. What are method? Methods are instructions, bunch of instructions, right? Okay. Let's start with class. What is a class? Class is an object. Class is an object. And what do we mean by object? Object is just anything, any tangible thing. Can be tangible, it can be intangible, but let's just say any tangible thing. Your phone is an object, right? Your your clothes is an object. The RGU is an object, right? Now let's take RGU for instance as RGU is actually much more than an object, but let's just say RGU as an object, right? Let's say school as an object. So in the class, which is an object, you can have different things the class is doing, right? So say RGU for instance, you can say okay, RGU is offering as school of computing, as a school of arts, stuff like that. But in the case of object and class, we say the class can have property and methods. Now, let me just, while we're doing that, let's just sing three Java. So public public class lab 3. So now this a class is we'll just use the common ways to use a class like a car. If you're not speaking, let's keep mute. Okay. A class is like a car. Is that a class is like a car? Your car has many functions. Your class is like a car. Your car has properties and functions. Now, when we say the properties of a car, we're talking of what kind of car is it? Who is the manufacturer? What color is the car? What's the size of the car? You get those are the properties of that car. It has many properties. It also has functions such as start, such as stop, such as brake, such as open the door or something, right? Those are the functions of the class of the car. Same thing with classes in Java, classes everywhere actually. Your class is like the car. So let's say this is your car. Then your car has properties. Let's say string color equals red, right? Okay, sorry. Public. Let's just have it for now. Let's say this is the property of the car, which is the color of the car, right? When we're talking of properties, we have not talked about it, and I don't think we've talked of constructor, so I won't really go into constructor today. But you can use constructor to manipulate the property of a car. It is also part of the property. It's a method also, but it's manipulates the property of the car. So we won't really go into constructor today. So let's just stick with what we know already. We know that a car as a class as a property and methods, just like your car has properties and functions. So function is the same thing as methods. So the properties of this cars, properties of the car, we have color, we have public string, manufacturer, right? We have any other thing like all the properties. How does the car look? What's the length of the car? What are the, when they say property, something we can use to identify something. So what can we use to identify this car? So let's just say this is a car. Rename file. Let's call it rename. Let's rename. Let's call it car. Okay. So we have our class as car. Properties of the car includes color and manufacturer. Then we have functions of the car, right? Now, when we're talking of functions, we are talking of methods and class. So we've seen main. Main here is a method. It's just like, what is the primary function of your car? The primary function of your car is to move or something. I don't know. But when we're talking of classes in Java, the entry points for every class is a main method. So you can have as many methods as you want, but the main method must always be present. So functions of your car. So this is like start, but we won't say start. We can just say this is you opening the door or something. Like the first thing you do. Like, okay, you wake up in the morning, you want to go to work, right? The first thing you do with your car is to open the door. So this is like opening the door for the car. But we can use a different name for this. For that first, like, you might decide to do opening door separately, but you must always have a main method. I hope you're getting it. So what is a method? A method is a function. So when we say a function is when we say something does something, that means it got an instruction from somewhere and it did something. If I say if okay, let's stick with a car, for example. If I say start, for instance, right, I have to supply something to the start. I can't just enter my car and the car will start driving. No, I have to give it something, if either a key or my thumbprint or my voice. Car start, right? That is an input. You are giving it something. The start is already there, but if you don't supply it with something, it might not start, right? So there are input and there are output. Now, the way car works, right, is not like somebody who just, let's say I want to build a car. I own a manufacturer, a car manufacturing company, right? And it's not just one person that will be working on the car. There will be different departments working on different parts of the car. There are different people working on the start engine, like the start, like that place you put your key and you kick. Somebody separate that is doing that. There's someone different working on the engine. There is someone different working on the tanks. There's someone different working on the doors. So the same thing applies to this one. So, for example, the things I've said, someone different is working on the start. So public static void start, right? The start to start your engine. That's the people working on your start. The people working on the door, public static void door, right? Let's say engine, public static void engine. Now, the way the car is supposed to work is you enter, you kick, then the engine starts. And we've already established that the departments working on start are different from the departments working on engine. That's fine. Now, when you supply your key to the start, that's your key is an input, right? So we can say, depending on the data type, don't forget the car is hypothetical. So let's say your voice, for instance, say it's expecting starts the car, right? So let's say that's a string, right? String word, right? Let's just say word. The sentence, the word that was, or the sentence that was altered, or start phrase. Let's just use start phrase, right? Something we're familiar with. Start phrase. Maybe your car has a particular phrase it needs to hear. So collect a start phrase. So if you enter and you say start the car is supposed to start. If you enter and you say, how are you? That's not a start, like probably how are you is not registered in the car. So it's not a start phrase. It's not going to start. Right? So your input. Now, your start phrase, your key, when you say that thing, starts the car. That start engine, that start box itself does something and supplies something else to the engine. Now, the start is supposed to give an instruction to the engine that, okay, this guy said we should start. Oh yeah, can you start? Can the engine now start? Now, that's three things. Now, you supplied something. The start engine collected it, did some things. Okay, is the start phrase correct? Is it supplied by the person that was supposed to supply it? Is this that? Once everything is true, then it supplies something. It calls the engine and it supplies something to the engine. Okay, engine, you can go ahead. So that is where the output comes into play. So the input comes here, the output comes here. So depending on the output, you can supply the data type of the output. Remember the data type from lab 1. You can now supply the data type for the output here. But it's a bit different. You can see that here you are supplying the data type of the input and the name of the input itself. But here you don't have to do that. You just supply the data type of the output. I hope this makes sense. I hope still together, please. Hello?
Yeah, we are together.
Yes, we're here.
Okay, great. So now let's try and build a car. Someone entered, right? We can say let's just say we don't, our door is the same thing as main. So we can say boolean someone entered equals true, right? So someone entered. So we can say if, or we can even say false, because basically originally there won't be anybody in the car. So at the end of the day, at some point, probably in the morning, then we'll come and say, okay, someone entered changed to true, right? Then we can say, okay, if someone entered equals true, right? Then start with a phrase. Let's just say start car. So when you entered, you say something, right? Which is start car. What's going on? What's going on? What's going on? Invalid character constant. Sorry, just a minute. What's going on? Okay. Let's be sure there's no. What's going on? I'm coming. I'm just trying to figure out why this is open is true error. Okay, invalid character constant. String phrase equals y phrase. Why is everything red? Okay, mind us. Okay, let's do that again. So someone entered was false originally, then you entered your car. So once you entered, someone entered changes to true, right? So then we want to say if someone entered equals true, true, then start phrase, supply a start phrase. The person that entered should supply a start phrase. So the person that entered should so we can say string. This was the issue was earlier. String, the phrase the person entered when the person said with his mouth when he entered was start car, right? Then we can say start. I don't think we need this one. I was just trying to check something like that. Start, then using the phrase. So this phrase, which is start car, is passed down to start phrase, and then inside the start phrase we want to check if start phrase equals start car. Remember this from lab 2, I think, if statement. If start phrase equals start car, then we can call engine to do something, right? We'll come back to engine. Else incorrect phrase, right? S out incorrect phrase. So what happened? Initially, there was nobody in the car. Then someone entered the car. Then once the person entered the car, we are saying the person should alter a phrase, right? You can even collect this from inputs. Remember inputs, remember scanner. Let's just a revision of what we've been doing before. My input equals new scanner system.in, right? We're collecting it. Then we say phrase is now my input dot next, right? Then the person, there was nobody in the car. Someone entered the car. If someone entered the car, ask the person to enter the phrase, right? Then pass the phrase down to the start button, to the start function, and check if the phrase that was entered was start car. If it is, call engine. So we can go to engine and just do some village thing. Engine started, right? So if start phrase, if what the person entered in the prompt is start car, then we can start the engine. Else, just tell the person incorrect phrase. So let's try this. We can just ask, right? S out, enter the start phrase. It's better to make things because most people will not really understand that you're asking something here. So ask the question, enter a start phrase, right? So enter a start phrase, we can make it on the same line, that's fine. Play it again. Enter a start phrase, so we enter start car, right? Oh, incorrect phrase, that's not good. Let's see what start phrase actually is. Debug, all the way debug. Print, start phrase. Start car. Oh, I'm only getting start. Why is that? Oh, okay, next. I think this is wrong here. Dot next line. Yeah, I think I need next line here. So let's play that again. Start car. Yeah, I got the whole thing. So I am I still getting correct phrase? Start car should be the same thing as start car. This is start phrase, right? Why am I getting correct phrase? The engines to choose start because I'm supplying the same thing. Interesting. Yeah.
Is it not start phrase? That's the one that will open it up because you have said here the string is start phrase and not start car. Even though you have said if start phrase is equal to start car, maybe that's where you can check.
Yeah, if you check here right now, my phrase.
Yeah, what is our phrase exactly?
Plus, yeah. So that's. So my phrase is start. Let me put the whole thing so I know. Start car, right? So my phrase is start car, which is car, which is the same thing as what I have here.
Okay.
Let me just check. Boolean check equals start phrase equals start car, right? Then check s out check. Why is it false? That's interesting. Okay. Okay. Just give me a minute. Let me confirm something. Next. Start. Fascinating stuff. Okay, this is interesting. Miss out. This is what I want to do today. Equals start. Say start.
Anthony,
Yeah.
see, after that if statement there, shouldn't there be a system dot out the print line? I think it's missing it because there is no print, there's no output there.
Which line? This is the line number. You can use the line number. Which line are you talking about?
25. After he said if.
25. If start phrase equals start.
Yeah, I mean, shouldn't there be a system that there is something to output, like something the system will output?
One thing what I was actually trying to say here that brought up all this confusion is that you can pass something through your method. So we're calling a method here and we're passing something through it, and it actually got here. You can see we're actually getting start phrase. It's just not equating. I don't know why it is not equating though, but it's not equating.
What I'm saying is, after you said if start phrase equals to start, then what is it you want the system to print?
I want it to go to engine.
Okay.
This is engine now. Engine will now print engine started. You grab.
Yeah.
Okay, this is not good. Let me try a different. Okay. Just take this out for a minute. Phrase is start car. Is start car. Still don't know why this thing is telling me. Sorry. Let me just close this thing and open it again. This thing does this thing sometimes. Where's my tutorial? Just open folder, desktop, tutorials, Java 3, open. Okay, so first is 1, right? I'll take this off and color. I'm just using integer instead of string. I don't know why I'm getting the. Okay, this is what I'm trying to do. I don't know why the string is giving me a tough time, but I'll come back to that. I just don't want it to take our time. It's just something wrong somewhere that I don't want to start looking into. Well, let's still do something interesting with integer. It's just string is trying to give me a tough time there. I check it out if you have time. So what I'm doing here is I'm collecting an integer here, right, from the here. Yeah. So I want to collect an integer. So if the person entered 1, right, you can see I've changed my start to also collect an integer, no more a string. So we are not collecting a string anymore. We are collecting an integer. So we're expecting 1. If the person enters 1, we start the engine. If the person entered something else, we just say incorrect phrase. Incorrect phrase. Basically, what I'm trying to show here is that you have several methods. This is your main method, this is your start method, this is your engine method. You can call each one of them. The only thing your start button will do here is to call the main. It now depends on you to invoke every other method when you need it. Right? The first thing I needed was my start method if something happened. Then inside my start method, after some calculations, if this is this and that is that and that one is that one, then either start the engine or tell them it's an incorrect phrase. So starting the engine means calling another method. So what I'm trying to show is you don't actually have to call all your methods in the main, but make sure you know when to call them. So right now, because this bit I'm explaining will actually come to play inside one of these examples where you are using the method inside a method inside another method. So you need to know how to change your methods. So if you need you can also call multiple methods here. You can call engine directly from here. That's fine. It works, but that means you are saying immediately you enter the car without doing anything, the engine should just start, right? So depending on your requirement, that tells you how you want to invoke your method, the process you want to use in invoking your method. Now, back to method. Method definition, you have your accessible, public. This is just accessibility, public, private, global. I think one more about it's just for accessibility. Static is also for accessibility. If you I don't want to explain this, but basically if you put static, it means you can invoke this method independently. And if you don't put static, that means it's changed, it's using some things from the constructor, and we've not done constructor, so that's why this might be a bit hard to explain. But just note these two as stuffs for accessibility. The most important one here is the return type, the return data type, the name of your function, and your input. Automatically, your main method will always collect an array of string. This is called array of strings. Then you give it a name. We're just calling it arguments. These things are called arguments. So we just say, okay, ARGS, right? You can give it any name you want, but the data type of this is array of string. So always the main method will always collect this, but your own method, this one is not collecting anything, this one is collecting something, right? And at the end of the day, maybe when I do this, I might want to return something back to main, right? So maybe I want to actually tell main the status of this function. So instead of calling engine here, right? Instead of calling engine inside main, maybe I want to call engine inside main instead of calling it inside start. So I can take it off here, and my return type, I want to return something to main. Let's say I want to return a boolean. So a boolean means I want to say, okay, if start phrase equals 1, then return true. So I want to say, okay, this person actually entered the correct thing, else return false. So if the person entered 1, I want to return true. If the person entered false, entered something else, I want to return false. That is why I'm putting boolean here, because I'm only expecting to return true or false. If you are returning 1, 2, 3, numbers, then you want to put the appropriate data type. This is return, this is input. This comes from someone else. This goes back to the person. So if I say, if I give you money, buy me sweets, this is where the sweet comes into, this is where the money comes into play. And this is where the data type of the sweet comes into play. Data type of sweet. Data type of sweet comes here. The money I gave you comes here. You are the function. I hope we understand that bit. Sorry, do we understand that bit? Hello? Hello?
Yes, we are following.
Yes, we are following.
Okay. So now I want to now say, because if you do this right now, we won't actually get to engine at all. The only thing we called was start. So enter phrase, even if I entered one, nothing happened. Right? We did not get to engine at all. But here I want to say, okay, I want to collect the result of start because actually I'm expecting something. I'm expecting a Boolean. So Boolean result of start equals start. If you put any other village thing here that is not what is returning, it won't collect it from you. You can see it will either throw the error here or throw the error here. You will see the error one place. It's saying type mismatch cannot convert from Boolean to int because start is a Boolean. Engine is void, so engine is actually not returning anything. So if you are calling engine and you are saying int result equals engine, then you will get an error. If you are calling start and you are saying int start equals something, int result equals start, then you get an error. It has to be a Boolean because the data type of start is a Boolean. So we say Boolean, right? Then we can go ahead and say if result start equals true, then we can call the engine, right? Else kick the person out. S out. Kick the person. If your car is a Superman, kick the person out of the car. Right? So all we are saying here is if the person entered one, start the car. If the person entered something else, kick the person out. But we are trying to make it more. You can see your code is getting a bit longer now. Now imagine if we actually did all the things that we needed to do inside start, we did all the things we needed to do. Imagine how many things happens before your engine actually starts. Imagine if you outpack all of them inside just one function here. So let's say your engine is like 500 lines of code, your start is like 250 lines of code, but you did not break them down. It's called encapsulation. You did not break them down. You just put all of them inside one method. Then you're going to have 750 lines of code to debug whenever you discover that, okay, you're not passing the right thing to engine. No, you're not even calling engine. Probably when you start the car, the back door is opening. Then you now have to be reading through 750 lines of code instead of just looking for the start button and checking, okay, this is actually the start button. It's just 4 lines. What is it doing? And okay, it's not supposed to open the back door button. Back door is supposed to start the engine. Then you fix it here. But if you don't encapsulate, you have to read through the old 750 lines of code and be looking for, okay, what is even happening at what point? It was given an example yesterday where it was trying to debug someone else's code and the person did not encapsulate, wrote everything inside one file, about 10,000 lines of code, and he needed to debug it. For the person that wrote it, he can't debug it. For he himself that is debugging is hell for him. So that's why this breaking things down comes into play. So you can have different departments. Different departments means different methods. I hope that makes sense now. So if I play these and put 1, my engine should start. If I play it and put 2, should kick me out. So kick the person out of the car. So that's method in summary. Because in summary, basically, you have your method definition, which is these accessibility options. You have your return data type, the name of your method, your input parameter or argument. Then your code block goes inside it. Now let's go to the business of the day. In the lecture, there is an example of how to create your own method to compute the circumference of a circle. Use this as a guide to create a method to return the given the area given a radius. Don't mind the English. So the formula of the area of a circle is given below. Circle equals pi r square, where r is the radius of the circle. So create lab3_1. So let's do that. lab3_1.java. That gives us a class. That's fine. Let's have a main method. Great. Create code store the radius of a circle as a decimal number, not whole number. So it's telling you to create a decimal number here. Now from data type from lab 1, you know that decimal can either be a double or a float, but double is the default in Java. So with that, yeah, we just stick with double. So double, r is the radius of the circle. So r equals radius. They've not given us yet, so we just declare it and leave it there. Create a code, store the radius of the circle as a decimal number. So we've done that. We don't have the value yet, so we leave it like that. Add code to assign a random value for the radius, which should be in the range of 5 to 10. So you're told to create I think this was in the lecture notes, but let me see if I can remember. We want to create a random number which should be in the range of 5 to 10. So random number, guys. Actually, I don't think I remember. So we'll just do this. There is math.random, but let me just use the one you used in class. So you don't complicate.
That's .pi, I think so.
No, that's pi. We're looking at random number. We're looking at getting random number. When did I do all this? Random. Yeah, math.random. And there's some form of the problem with math.random is it just gives you from 0 to 1. Everything between 0 and 1. So let's actually just take it one step at a time. So your math.random is going to give you a double. So double round. That's just the name I want to give it. Math.random. Right now, if you check this s out rand, you discover that everything you will be getting will be between 0 and 1. You can see 0.9. Let's do that again. 0.4, do that again. 0.2, do that again. 0.1, do that again. 0.8. So you'll be getting something within 0 and 1, between 0 and 1. 0 excluded, 1 excluded, but everything in between it you're going to get. You might get, not that it's. So how do we now get our stuff out of rand? You can multiply it. Let's say we want something from 1 to 3. You can multiply it by 1. So you can now say multiply by 3. Right? Is it multiply by 3? Is it multiply by 3 or yeah, it should be. 5 and 3 plus 3. Let's multiply. What am I looking for? S around. Okay, yeah, so we're getting there. That's fine. 1.7, 1.4, 1.4, But let's actually, I think I'm missing something. Is he using math.random or random? Okay. There is math.random. There is also a random class in JavaScript. I think he's using random. Yeah, he's using random. So we just use the random class. This is random, just generate random stuffs for you from the math class, but there is also random class itself. So let's say random class double, no, not double, random. The data type is random. Random rand1 equals new is a class, so you have to declare that first. Then you can say my rand. Let's just call it my rand. Then you can say double rand1 equals my rand. Sure. My rand dot next double, then a range plus minimum. This is actually complicated. I have to do it. No, just do copy and paste here. So range is your minimum according to the question.
5 and 10.
5. So your minimum is 5. Your range is 10 minus 5. I will explain this in a minute. Let me just run it and make sure we're getting what we're supposed to get. Round 1. 5 and 10. Yeah, that's fine. Okay, I'm still getting this. I'll just take this off. So 5 point something, 9 point something, 8 point something, 5 point something. So I think I'm getting between 5 and 9. So now maths.random is a class. I don't know how to explain this, but it's just not how to use it. That's the only thing I can say. Even me, I will still go back to it before the exam and make sure I cram it so I know what to write when it comes out. So basically, math.random is a class, right? This is, you remember Scanner. How you use Scanner, right? Scanner was a class. The first thing you want to do is you want to get yourself a scanner. The data type was scanner. Then you give your scanner a name. My scanner equals new scanner. Although scanner is a bit different because it collects an input system. System dot in. It collects an input. Then when you want to use it, you can say my scanner. Let's say int number equals my scanner is coming up dots next int, right? The same way you use this, the same way you're using scanner here. I don't know why my VS Code is doing glitch thing to do. Don't mind it. The same way you use scanner, right? You can remember us using it to get something here. My input that we collected from scanner. The same way you use scanner is the same way you can use this. So from the explanation of class and method I explained earlier, scanner is a class. Next int is a method of the class. The same way you have car as a class and start as a method of car, engine as a method of car. So someone already created something that looks like this called scanner. So the class name was scanner, and they created something get int, something, sorry, is it get int or next int, next line, next double, like different methods. So that's the same way you create your own, and that's the same thing we are calling. So random is a class that was created by someone, that has been created by Java themselves. Random is a class. So how do you use it? Random.next. Let me see if it has other methods. Let me see. Okay, you can actually get, int. So let's say next int bound SF5. I just want to see what that is. Int. Yeah, so okay, that's 1 to 5, I think. An integer number from 1 to 5, right? I don't know if it takes okay, origin and bound, so we can say 5 to 10, I think. Yeah. So if this is actually more interesting than maths.random, because you have to do some calculations here. But for here, all we need is actually O number, I think. Add code to assign a random value for radius, which should be in the range of 5 to 10. Actually, a radius could be decimal. A radius could be decimal, it could be an integer. So, but let's say we are talking of things that are O number. It's just easier to use to use the random class, then collect next int. So what you get is O number. If I change this to double, which is a decimal, and I say
Next double.
Yeah, and I say next double, what I will be getting is decimal numbers. So from your origin to your bound, right? And I don't think this thing that I was doing in class is actually necessary, or this route that is taking us to. This one works also, but I think this is just easier. Or what do you think?
Yeah, it's actually unnecessarily too long.
Yeah, doing this and just defining your start from 5 and at 10. I think this is a bit shorter, right? Forget, okay, if you're looking at my screen right now, you will see some weird thing that I did not write that came up. They are not part of my code. This origin and bound here, they are explanations. They are not part. I did not type this thing. You will see that if I delete 5, the origin goes with it. If I delete 10, the bound goes with it. So I was not the one that typed it. It's just my editor, my IDE, that is doing these village things for me. It's just me that I'm typing it. It makes you understand. But if you are looking at my screen, if somebody wants to copy this code, they might land in trouble. Don't copy origin as part of this thing. Don't copy bound as part of it. They are not part of it. I hope you get that. It's just an explanation of what is going on. It's telling me it starts from 5, origin is 5, and the maximum is 10. I hope we understand this. Origin is not part of what you want to type here. Bound is not part of what you want to type. Does that make sense? Hello?
Hello. Yeah. Yes, it makes sense. I'm having I mean, I don't know. Maybe we can go on first. I was having a question regarding the suggestions. You know, like, as you're typing, is it because it's giving this suggestion? First of all, is it because you're online? That's the first. And the second thing, these are bound to the Visual Studio. That's why it's giving all these suggestions, perhaps. But during the exams, of course, we are not having the internet. these suggestions, will they still come? Because, for example, it's easy just to write salt instead of starting to write static, blah, blah, all that thing. So I don't know if, how will that be? Thank you.
Yeah.
Please, can I say something?
Sorry?
Please, I'll say something. Can I say something? Okay. So, this origin and the bound, it is, what's it called? Because what we are using is already inbuilt. So the parameters that you have when you are constructing it, if you are using a constructor, for example, is origin and bound. So it comes out automatically and it has nothing to do with your code or anything. It's just telling you that whatever you set initially inside this class, whatever was set when they were constructing this random class, do you understand? The parameters inside was origin and bound, right? So whatever you're passing is origin and bound from the constructor. Because the constructor just sets it, doesn't give it value, but down here you are giving it value. Then I want to say something.
Okay.
These 3 lines that we're having here, like you were saying, random is a class. Now, when you say my rand, you are creating a new object, right? And because you want to return something, you are forming a new variable called rand1 before you now assign your new object with the method that was originally built inside random. That's the second line. I just wanted to explain something about methods there and objects. So class, anytime you have a class, you must create an object for you to access the values inside that class, right? So that's why, but because this class that we created or this method is returning something, you need to store it somewhere called double rand. I don't know if I'm making sense.
Yeah, that makes sense.
I just wanted to add that.
Thank you very much. Back to Eunice's question. Let me see if I can still remember that. It was talking of Eunice. Can you take that again, please?
Yes, I mean, it's clear what she said. Thank you very much regarding the origin. Yes, it's not part of the code. This is part from the construct, and these are sort of suggestions that are coming out. So we shouldn't worry about that. Thank you very much. I think that is what I got. But I had a question now during the exams, because you're going to be, first of all...
During exams, thank you.
Yes.
Yeah, during exams, from what you said in class, we will definitely be using VS Code. And if all goes well, it's technology a bit complicated these days. If all goes well, the things, the suggestions should come up. You can see me struggling with some, even my own that is working there. Sometimes I'm struggling to get the suggestions to come out. So there are, when Satan wants to do his village thing, I don't know if anybody's watching Satan here. I'm not. Well, if your enemy wants to do their village thing, that suggestion will not work. But I'm praying it will work. I will also ask to confirm that. Yeah, we'll be running a test on, like you said, we'll be running a test before exam. So we'll confirm all these things before the exam date.
Okay.
So once we have that test, we know what to expect and what to go and start cramming.
Oh, yeah. Well, that's for some of us who actually get debug stuff deep.
Once you are doing the test and you discover that next double is not coming out when you type my rand, then you know you go and start cramming what are the methods that they might ask for in a random. What are the methods that they might ask for in scanner?
Yes, exactly. That's was the issue. Anyway, we will try.
I'm hoping the suggestion will work though. I'm hoping they will work.
Thank you very much.
Yeah, so that's that. So instead of this works fine, I just think this is a bit interesting. This is a bit short, just your double. Then if you put just one thing, that will just be the origin. It means you should you should end at 10. So you have something between 1 and 10. So you are using double, you are collecting next double, which means 1.1, 2.5, 7.6, 9.9, but you can't have 10. But you can have 9.9999 as long as possible. But if you're using integer, then you are saying 1 to 10. O number 1, 2, 3, 4, 5, 6, 7, 8, 9, no 10. Right? So, but if you're having two things here, which means you are saying it should start from 5, end at 10. It should start from 6, end at 10. I don't know if this makes sense. So according to the question says we should collect a double. It didn't really say if you should collect a double or a float, but this is where your own common sense comes into play. From your mathematics in primary school, your radius is always in 2.3. They don't normally say the radius of the circle is 2. It's always 2 point something. So I think both will work. Both will give you your marks. Both will work fine. I'm just talking of marks now. But both, they should mark both correctly, but it's just better to go with convention. So let's just say we are expecting a random value from 5 to 10. Now code a method to return the area of the circle. So it's telling us to create a method. They already gave us the name of the method, area of a circle. So public static void, we'll come back to void, area of a circle. Don't forget your method name, not just method name, any name, file name, class name, method name, variable name, they don't have space. Your file name, even in Java, your file name must not have space. And that was why I keep telling people, even as now, even when you're not dealing with Java, you're not dealing with Python, when you are naming stuff now, try and to make yourself conversant with it, anything you are naming, make sure they don't have space. Underscore, put underscore, or use a camel case. They don't, file name, class name, method name, variable name, they don't have space. Don't forget. Don't go and write your village area of a circle. If you write it like that, it will not work. So it's saying we should code a method to return the area of a circle, and this is the area of a circle. We can just copy it. We cannot copy it actually because we don't have pi. That is the second thing we'll be coming into. So area of a circle, because we are doing some multiplication and stuff, and like I said, the radius we are collecting is actually a random number. So at the end of the day, our area, what we need as the area should also be a double. So we could just say double area equals pi r squared. What is pi? There is a method in, is it a method? There's actually a property. I don't think it's a method. There's a property in maths. You know, we've been seeing maths before. We saw math.random. We saw, I don't know, have you seen other maths? Yeah, we'll see other maths in today's class though. But there is also a math class. So there is math.py. Right? There is math.py. It's not a method, which means you don't need to put, it's not even need, you must not put this bracket. It's just a property, math.py. That will give you the pi. If you do this, let's just do it very fast. System.debug. S out. Nope. S out. Math.py. Let's see what we get in a minute. Yeah, you can see 3.14142, blah blah blah. So that's your pi. So that gives you your pi in a double format. So math.py, we'll see much of these methods. I think one fear from myself also and from some people I've spoken with is it's actually general stuff in programming. You are not expected to know everything. I am not expected to know every method in scanner. I'm not expected to know every method in maths. I'm not expected to know every method in the random class. But when I want to use them, I can always Google how to, let's just do it in a minute. There's my browser. How to do what? How to write pi in Java. Pi value. Yeah, you can see. You just have to be able to read. You can see how many things I've skipped at the top, but I know what I'm looking for. So that's your pi. So math.pi times, what is r square? R square is just r.
Radius.
Sorry?
Is that radius?
No, yeah, radius. I'll come back to. I'm just trying to type out this formula. So r square is r times r, right? But when we have r raised to power 10 or r raised to power 100, this might be complicated. So there is also a math formula for a math method, a math function for that, which is math.power. Now, math.power collects two inputs. This is a method. This is a property. That's why this one has no brackets. This is just a property of one of the properties on math. But this is a method. It is doing something. It's an action. Pi is just a value. Power is an action. I hope you understand the stuff now. Color is the value for the car. Start is an action. From what I explained earlier. So pi is a property of math. Power is an action that is doing something. So you have to supply two things. You can see the method definition. You have to supply two W's, but we'll explain what each of the W is. The first one is the value you want to pi. The value you want to power. So the first value is your R. The second value is the power. The first value is R. The second value is power. So this will be R, and this will be 2. We don't have our R yet, so we are expecting an R, because it's like you are building a calculator, right? So you have to supply what you want it to calculate. Go back to the question. The question says, code a method to return the area of a circle. The area of a circle needs radius. Before you can calculate the area, you need the radius. So you need to pass in your radius, and your radius, don't forget your radius. This is where we get the radius from. We'll get to that in a minute. We're expecting a double radius. So double radius, right? Then that will be our R. This is not doing anything right now, but when you need it, you will call it and let it return. It says code a method to return the area of the circle. This is the area. The data type of area is double, so we can easily change our return type to double and say, okay, it's already telling us something is wrong, but we know how to fix it. Return area. You get? So you have your formula, you return it, and make sure you are using the same data type as the return data type. You get? Your method doesn't do anything. It's just like you are saving stuffs for rainy day, so that when you get to class tomorrow and someone says, okay, I need the radius of a circle I need the area of a circle with radius 2.4. You don't need to start, okay, sorry, what's the formula for calculating radius? And what is pi? What is this? You already have a code kept. So by tomorrow, when somebody does that, you can just easily come out and say, okay, you want the radius of pi. Okay, sorry, you want the area of a circle. So area of a circle. Okay, what is the radius of that circle? They say, okay, it's 2.4, that's fine. Then you get your area. even if area of a circle is not in this file, random, you don't know where this random is coming from and you are using it. Imagine if you have to code random from the beginning to the end before you can use it. That's the same thing we are doing with this area of a circle. Once we have it now, we don't need to code it anywhere. Probably I'm in my car now and I still need that radius of the circle. I don't need to start looking for the formula again. I just call area of a circle and I supply a particular radius to it and I get my answer. So that's how it goes. It's just a way of saving an instruction for later use. Like I said, it's an instruction. Until someone gives that instruction, it's not supposed to do anything. So this is an instruction. Then, because, like I said, it won't do anything. So even if you run this code, it's not going to show anything. Even let's out area. Let's remove some things from here. We'll bring it back in a minute. SR area is not showing anything. Even though we said you should print out something, your code is never getting here because this is a separate method. The only method that get calls when you play is main. So if you don't chain any other method to your main, it's only main that will run. But okay, we are actually trying to calculate an area. So I can say, okay, double area equals area of a circle, and I supply my rand, which is rand 1, right? My random number that I'm generating. Are you serious? I can just show the random number to be sure everything is still fine. Round 1, right? And also S out the area. The area of the circle is plus area, right? So I'm printing the rand value that I'm generating automatically and I'm printing the area. So instead of coding all these things inside here, I don't have to do that. Let me take this off so we don't complicate things. So I use a different method to calculate my area. Then I just call the method. Bam. This is the what's it called? This is the area this is the radius that was generated. So let's try and calculate that. 3.142 times times what's our area? 9.8 times 9.8. So we get 3298. Yeah, the reason why ours is a bit farther is because of decimal. Let me just copy everything, right? And this will be somehow close. Let's also get pi, so we know this is my random number. This is pi maths.pi right? So let's play that again. So let's do the calculations ourselves. This is a random number. That I hope you can see my calculator screen. Hello?
Yes, yes.
Ah,
Yes.
Anthony, we are with you.
Times, let me copy my pi. Pi is 3.142. So we get 99.14. You can see it is actually correct. The reason why that one was way off was because we neglected all these values. That was what I was explaining to someone in class one day about these values. When you add them together, at some point they start. Imagine your balance in the bank is supposed to be 3.04 and the teller is telling you your balance is 2298. Fight will start. So that is why precision makes more sense. So if you are not precise, if you miss some values, your calculations might be way off, even though you think they are small. So when they are in greater, like even if they are small, if you have much of it, a drop of water from your tap, before the next morning your this thing is full, your bucket is full, even though it's just drop every minute. But when it gets much, you start losing precision. So that's why it's better to be a bit precise, and that's why Java makes double their default decimal data type. So that's that. So we have the area of the circle. We can continue. The main method invoke the method you created to display the area of the random radius, and that is all we just did. We invoked it, and we used the value of the random number we generated. Run the program, so the output is like the one shown below. So you can just panabit your output to look like this. So I'll just do area of radius. I'll use F to make things easier. Area of radius percent. You remember printf, right? %2f is %.2f, then we supply rand1 comma area. So what we are saying is area of radius rand1 is area. Then we are formatting it to 2 decimal places. Play it again. Area of this is this. Let's give it a new line to make things to reduce conjecture. So area of 5.79 is 105.18. That finished that question. Now, write to dice program. The game is about rolling 2 dices, and if the sum of the 2 dices is 12, 2 6s, you win. Otherwise, keep on throwing the dice until you do. Now, this is interesting. This is the final output we're expecting. So you are expected to roll 2 dices, right? Then we want to keep track of what you are rolling on both. You have 2 dices. You roll the first one, you get a number. You roll the second one, you get a number. We add the numbers together. Then we check if that number is 12, right? Don't forget your dice only has 6 faces. So do we have a, yeah, we have this, but they did not. So dice.java down. So it says, let's have our main method. Main. Let's do this. You remember what I said about this pseudocodes makes things easier. So I'll just follow it. Let's see if we can get somewhere. Just make it comment so they don't mess with what we have. And they are bits. So from get to increase, and from display to exit. Those indentations are very important. It makes you know who is the father, who is the child. This is while is the father of all these ones, if is the father of all these ones. When I say father, I mean they are under. So the brackets start from here, ends here. Okay, so the first thing is we want to keep number of tries. So we say int tries equals 0, right? Boolean throwing because we have, this is actually not a good way to learn, but let's try and understand the question, right? Because I could just be typing like this, we think we know what we're doing, but we are just following. I have explained it earlier. You have two dices. You want to keep dropping. You want to keep dropping dice two times on every go until you have 12, and you want to keep count of how many tries you make. So that's what this number of tries is for. And because you want to keep doing things, you want to keep throwing two dice every time for till a particular condition is met. That means you are talking of loop. You are talking of loop, right? So you have a loop that keeps doing it until, that is your condition, until you have 12. Now your condition is my total 12. Also, you want to keep track of your totals. I hope we're getting that. So you want to keep track of your totals. You want to keep track of your what's it called? You want to keep track of your you want to keep track of your totals. You want to keep track of what you are dropping on of your trials also. So let's do it. There are two ways to get our, so let's do our while throwing is true equals true. Then we open our this stuff. We can copy everything, put it inside. Like I said, we can just do like this. And where does it stop from here to here? Well, they actually have the bracket, so we just do this. And yeah. Okay. So you have your while throwing is true. That means throwing, you keep on throwing, gets the first dice value. So our dice value, integer, your dice will always be an integer. So int dice 1 equals what? Do you want to collect it from user, or do you want to just use random number? Any suggestions? They didn't really say how to get it. Just said they should keep throwing. Any suggestions? Should we use random number, or should we get it from user? I think we should use, this is actually using random number, so let's just stick with random number. So let's bring in our math.rand. Sorry, our random number. Let's just call the let's use the class random. My random equals new random, right? And I can use now one mistake you don't want to make is scope. You could have brought this random and put it inside this while. Sorry. Don't make this mistake, because the thing is, what you are doing here is every time the person wants to throw, you are going to buy, let me use a common term. Let's use the scanner, for example. You bought a scanner. Like I said here, where is it? When you want to use scanner, it's like you are buying it. You go and buy it, right? Then you can now keep using it. Now, if you are buying, don't forget you will be using money to buy. Let's say you are buying it for £1. You are now putting it here inside this while loop. Don't forget, while loop is doing something forever, which means every time you want to throw the dice, you are going to buy another scanner, even though you have one before. So once the first throw, you threw 3, gave you 6 wrong. You start the whole process again. You buy another scanner, you throw, it gives you a wrong value. You start the process again, you go and buy another scanner. So imagine how many scanners you will have. Like this one, for example, now would have bought about 1, 2, 3, 4, 5, 6, 5 scanners. This is wrong. Your code, I'm not sure if it will work, but this is just wrong. When you're doing things like this, that you see you are doing the same thing, you don't want it in your while loop. You want it outside, where just buy it, keep it in the kitchen, and anytime you want to use it, you can just say that random that is in my kitchen dot next int, which is from 1 to 6, 1 to 7 actually, 1 to 7. I don't think the bound. Let me see if I can read. Mat the random class. Java random class next int. Decline all. Close, please.
Pi times the radius squared. What you do in this program is accept a radius as input from.
Trying to see. This is not a good document. I just want to show you how to get. I can check it, but I don't have the time. How to be sure of this thing. Okay, you can see if I put 10, it means 0 to 9. You get. So if I put 1 to 7 here, it means I'm expecting something between 1 and I may actually not need 1 again because it will definitely start from 1. I need between 1. I need 1, I need 2, I need 3, I need 4, I need 5, I need 6. But 7 will not come up. That's the whole idea of me putting 7 here. So my dice 1 is 7. My dice 1, I'm collecting it from random. I'm also collecting my dice 2 from random, another random, equals my random dot next int. Yes, this is 7 because it's a dice, so it only has 6 faces. So that should be dice 2, right? So dice 1 we get a random number, dice 2 we get a random number. Then we want to add both numbers together, right? So we want to add both numbers together. We want to say, okay, that was also be an integer sum equals dice 1 plus dice. Okay, I'm actually following a document, don't mind me. So we've gotten the first dice, we get second dice, sum both values, so int sum equals dice 1 plus dice 2, right? Display the score, S out. Let's see how they display the score. Okay, there's the values, sum plus they are putting something in front, right? We just put it together. Like this is the total of the first stuff, this is the total of the second time, this is the total of the third time. So plus just put this place, yeah, just make things interesting. Why is that? Oh, okay. Sum is an integer, and we are concatenating it with a string, so we need to convert the sum to a string. So str sum is how to do it. Valid character. This thing has started again. Okay. No, that was. Sorry. I'm bringing Python into this class. Don't mind me. Concatenating. I think this should work. We can just run it for a bit, and if we run this, we'll be in trouble. If I run this right now, my system will be in trouble because it will keep on throwing it forever. You can see that I'm in trouble forever. Or you can use Ctrl+C to take yourself out of the trouble. So, and I think what we want is minus, not underscore. So I think is looking alike, but we want it on the same line. So I will remove the line. Then it says if sum equals 12. So I will do that. If my sum equals 12, then display the message. I'll bring this in. Display the message you want. I'll just S out again. You've won, right? Else exit loop, continue through. You can see, I think I missed some things there. Yeah. Oh, before I actually do that, once the person wins, I want to stop throwing. So how do I stop throwing? Can anybody suggest how I can stop throwing? Because right now it will keep on throwing forever. Can anybody suggest how I can stop throwing?
You change the Boolean throwing to false.
Thank you. Throwing equals false. So by the time it goes back here and say, wow, throwing is true, you discover, oh yeah, throwing is not true. We're done. That's it. So we'll stop that. Exit loop and continue. Okay, this is part of this. Okay, that was what we actually did here. Okay. Then increase the number of tries. That's outside, right? Increase while inside the loop, increase the number of tries. So what is our try? Our tries, we just do tries plus means tries plus 1. Try equals tries plus 1. That's the, I just use, when you hear anything increment, just use this. So that's that. Then it also says display number of tries. So S out 2Q 5 tries. So I'll use printf, that's easier. 2Q %d tries, d for integer, because I know my tries is an integer, right? So tries. Okay, let's see if we've done glitch thing. Yeah, took him a lot of time. Well, we worked 1, 6, 10, blah 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 until he actually got 12. Then he took it. Okay, let's break this. /n. Let's do that again. Yep, took it 63 times this time around. Took it 60. This person's system is very good. just 5 times. Mine is doing it. So what is doing here is for each of these 2 right now means 1 1. This 7 right here means probably 3 plus 4 or 4 plus 3 or 2 plus 5. So each of these values is actually the summation of 2 dice. Don't forget what we're doing here is a summation of 2 values. So that's why we could, but the only thing it could generate is between the number 1 and the number 6. All right. So that's, I hope this makes sense. Does this make sense? Hello?
Yes, we are studying it.
Yes.
Okay.
Yes.
Yeah, great. Okay, so we're done with that. You can see public static. We have the dice, we have the score, we have the tries. They are not showing score. That's why I did not include score. And I think this, depending on how you want to do it though, but I think this is better than this because right now you can get dice 1 and dice 2 separately inside their loop, but both of them will still work fine. But I think this might be a bit complicated. But this is fine. Yeah, let's go to the next one. write a dice program. I will actually not be creating a new file. I will just be building on the same file so we can save us a bit of time. Am I still together? Why are you doing that? Okay, thank you. Stop doing that. Write a dice program. And in the previous exercise, you have created a dice game which runs only one time. Modify the code so the game runs 10 times and compute the total number of it took you to complete these 10 games. Okay, all they are trying to say is that instead of this thing running forever, right? This is running 61, this is running 90, 63, this is running 95. They want it to only run 10 times, right? Then we'll still display how long it runs. So you can see this and this actually looks a bit alike, but there is a condition here. There's a condition here that is saying it should only run 10 times. So that will be while continues through. Hold on. Okay, let's follow the stuff and see. So we'll just introduce for loop at the top of train before while, right? Now we introduce, you have overall already. Increase the number of tries, and after that we want to reset the while loop. There are different ways to do this. I think I did something different while I was doing mine, but let's see where this would take us. That will be after the while, somewhere here. Then display the number of tries. So what they are saying is, okay, how do you do a for loop? For you can use any variable for int x. That will be, just follow me, equals 0. X is less than 10. X plus plus, I will explain in a minute. X plus plus. And reset while loop continue equals true. Okay, now we'll go before this. Our own continue is train. Train equals true. Let's run that and see what we get. I hope we don't run in trouble. Okay. Trying to understand what we did. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 10. So, okay, what they are just trying to say is you do it 10 times. Right? You play the game, you win 10 times. So in the previous example, you have created a dice game which runs only one time. Modify the game so that the game runs 10 times and compute the total number of time it took you to complete these 10 games. Okay, I'm getting the idea now. This is a typical situation where you must nest a while loop in a for loop where a few changes can be done. So basically, what we did here was, you can note that I didn't touch any of the code we wrote before. So no, not from here. Everything I said before is valid. Now, what they are now saying is that for each of, let's go back to this place. For each of these games, they want us to run each of these games 10 times. That means you have to win 10 times. You have to win 10 times. So once you win the first turn, we start another round of games. Right? So once we finish the first round, we start the second round. Once we finish the second round, we start the third round up until 10 games. So this is how to write a for loop. Your initialization, you initialize an abstract variable, then you have a condition. You are checking the condition, you are checking the abstract variable against a particular value. In our own case is 10, right? Then on every iteration, once the iteration is done, like once each of the iteration is done, you increment. So what we are doing here is initially our x is 0, is x less than 10, that's fine. Then we'll go through the first game, we do our while loop, while true is true, we keep on doing it until the person wins, and we change true into false, right? We change true into false. Then once we change true into false, which means the person has won, we are out of this while loop, like we are done with this while loop. Then we can go back, reset. We already changed true into false, but we want to reset our while loop, so we have to go and change true back to true so that we can start a brand new game. Then x equals 1 is 1 less than 10. The incrementation, right? We increment that 0 plus 1. That means our x is now 1. Then we check, okay, it's 1 less than 10. It is. Then we start the game all over again until the person wins. We change true to false. We change true into false. Then once true is false, we are out of this while loop. You can see the while loop actually stops here. So once we are out of this while loop, we can go back and say, okay, we actually want to reset. You reset the game board. This is like resetting the game board back to true, back to like 0-0 if it is match you and Chelsea. Once they finish the first, maybe they want to play 10 games in a day, if they can do it. Once they finish the first game, they go and change the scoreboard to 0-0. That is what we are doing here. We are changing the scoreboard to 0-0, which means we are just saying true equals true. Then we'll start again by saying, okay, we had 1 before. That's 1 plus, that's 2. It's 2 less than 10 up until we get to 9 or we get to 10. So we'll check, is 10 less than 10? Is not. Then we are done with this for loop. Then we can go ahead and do this. But we have to do something. Yeah, I think we're still. Yeah, our total try is still working fine. So you can see that if you now add up all these numbers from each of these games, you discover you have 423 games in total. So that's about 40 games on average. So I hope this makes sense. They are just trying to they are trying to do this whole part 2 10 times. You can notice I did not actually touch part 2. I only added a condition on top of it to say, okay, do the whole of part 2, do it 10 times. That gives you part 3. Now let's go to 4. In the previous exercise, you have created a dice game which runs 10 times, modify the code so the games run 10 times, but add an extra rule which stipulates that you only have 4 attempts to win the game.
Hello, Anthony.
Sorry?
Sorry that I had to jump in. I was raising my hand. He didn't say that. Okay.
Sorry?
Can you hear me, Anthony?
I can hear you.
Sorry that I had to jump in. I was raising my hand, but you didn't say that. I want to ask if it's possible for you to just go through that last while loop just one more time.
The while loop or the for loop?
This one, the one that has for loop inside the while loop, the for loop, yes. This one, just one more time, please, if you can.
Okay, basically, take them separately. Forget this while loop for now. Forget the old while loop. What we are doing here, we are saying, okay, for X, this is something you have to know. And this is actually the same for almost every programming language, but you have to know it. For int x equals 0, this is initialization. X is less than the value we're giving, which is 10. Sometimes you might have to calculate the length of something, but this has to be a value here. Then you are incrementing. So this is initialization, condition, incrementation. I hope this makes sense. That's your for loop. So you are saying in your for loop, 10 times I want to, let's just do something outside somewhere. Let's see, one quick minute. For loop dot Java, right? Then, so I'm saying for int x equals 0, x less than 10, x plus plus, s out x. So all I'm saying is for 10 times keep printing the value of x. So x is 0, print it. Is sorry, before you print, is x is 0 less than 10. Yeah, fine, print it. Once you finish printing, you increment. So x is now 1. It's 1 less than 10. Yeah, print it. Goes back, increment 2 until it gets to 10. It's 10 less than 10. No, then we're done. You won't print 10 because 10 is no less than 10. Does this make sense?
Yes, please.
Great. So now let's also do while loop before we leave this place. While condition, right? Then we can say, okay, what is our condition? Condition equals true, right? Boolean is going to be a Boolean. While condition, right? What is condition? Condition will either be true or false. 2 equals to 2 equals 2. You are trying to compare something. Tony equals Junus. That's not equals. 517 is greater than 245. That's false. So it's what we are expecting here is an expression that amounts to either true or false. And we are easily saying, well, we are using condition because we also want to use, we could have easily said true here. Well, if we said true here, there is no way of coming back and changing this true to false. So that's why we are using a variable called condition. So we can always manipulate this condition anytime we need to manipulate it. So while condition is true, we can also do some things outside x equals 0. We can even use that actually. Integer x equals 0. Then we can say if x, while x is less than 10, just like the same thing we have for the for loop, while x is less than 10, then s out x and also increment x. Now you will see that they're actually the same thing as this one. We initialize x, we check if x is less than 10. That is what we are doing here. We incremented x. It's just that the mode of doing it is a bit different, but it's all the same thing. You have a condition. You should always have a condition. You see 0 to 9, the same thing. So while loop, for loop, they are all about doing something for a period of time. Let's go back to the dice game. Now, you understand the for loop. Everything inside it, we just want to do it 10 times. Now, what are we doing inside it? We are playing a game whereby we are throwing the dice. We keep throwing the dice. We are throwing the dice 2 times. For each game, we throw the dice 2 times. We throw the dice 2 times. We add the value for each of the dice. Then we check if the summation is equals to 12. If the summation is not equals to 12, we throw the 2 dice again. If it's not equals to 12, we throw the 2 dice again until the 2 dice gives us 6, 6, which is 12. That's the only thing that can actually give us 12 because we're only getting from 1 to 6. So until we get 6, 6 on both dice, then we can exit the while loop. Now, not what we are doing here. Not this is yellow, this is yellow. What we are doing here, we are not dealing with for loop now. So forget the for loop now. We are dealing with while loop now. So we keep on going and coming, going and coming, going and coming. We are still inside the for loop. But the for loop, at the first inning, the first loop, sorry, at the first iteration, the first loop is 0. So while x is 0, we keep dancing and dancing and dancing and dancing and dancing, going, coming, going, coming, going, coming, until our summation is 12. Then we exit this while loop. We exit the while loop. Don't forget, once we exit this while loop, this is the only thing that will make us exit the while loop, which is changing throwing to false. That exits us from the while loop automatically. Then we have to, because we want to start a new game, we now say, okay, since we are starting a new game, throwing is false. One thing you can do is that you can actually bring this throwing to the top here to make things interesting. But it's fine if you still want to leave it here. I was just following if I was writing this myself, I would have put the throwing at the top, which means once I enter the loop again, I say, okay, my throwing is now false. New game, blank new game. Then I start the dance again. Now my X is 1. And I start the dance. Throw it. No. Throw it. No. Throw it. No. Throw it. No. Throw it until my sum is 12. I exit the loop, the while loop again. Let me put this at the top to make this thing more explainable. I exit my while loop again. I come back to my for loop. I change my X to 2. I change my throwing. Don't forget, my throwing is now false. Once I'm exiting the loop, my throwing is false. Which means if I don't do this, this thing will not run. Once you just check, oh, we've already said throwing is false, so I don't have to do it, then that's all. I just keep on coming, and my throwing will always be false. That is why I have to do this and say, okay, once I change X to 2, change throwing to true, then once it comes to, throwing is actually true, then start the dance again for the 3rd time. Until it throws something that is 6-6. Then we exit the loop again. So the loop here is different from the loop here. We can do something 1 million times here without touching this loop. We do it 1 million times before we got 6-6, then change this to 3. Does this make sense?
Yes, it does.
Yeah, thanks. So 4. Okay, I think what 4 is just trying to do is so we don't have. Let's just run this thing again to have yeah. You can see we're having long trials. Some people might do this thing for 1 million times before. Some people are very unlucky before they will get 12. So we don't want those kind of people to imagine we have only 2 dice and the whole of computing, school of computing wants to play. So everybody gets to play. For each of the while loop, they can only do that dance. Instead of doing this dance 1 million times until you win, you can only do the dance 4 times. Whether you win or lose, get out. But this dance is different from this dance. Don't forget. You will still do your dance, you will still do 10 rounds, but inside each round, before you can, inside one particular round, you can do it 1 million times before you win. We will just wait for you until you win. Then you will come back, do another one. You do it 10 times, then you go home. You get? Which means at the end of the day, you can do it. Let's say you are doing 1 million times inside every dance here. You can actually do 10 million because you are throwing it 1 million times before you got 12. So you can do 10 million before you actually leave the game. That is what we have here right now. But let's hope you don't do 1 million because we'll sleep. In the previous exercise, you have created a dice game which runs 10 times. Modify the code so the game still runs 10 times, but add an extra rule which stipulates that you only have 4 attempts to win the game. So the win here, another condition is coming. So if you don't, you lose. So which means what it's saying here is you have 4 attempts to have double 6. If you don't, you lose. So there is now a lose. You shouldn't always win. There is now a lose now. Hence, you are more likely to lose. This add more complexity. For each game, we need to track the number of tries greater than or equals to 4. This means that when a particular game completes, these values must be reset to 0. How do we track the overall number of attempts? We need to add another variable that will increase for all 10 games. So what we're doing is we have a working code right now. We want to add something. We want to keep track of something else. How many times is this guy doing this while loop? I don't know if you get that. How many times is this person doing this while loop? So if this person has done this while loop 4 times, we will change true into false. That is what we are trying to do. So overall number of tries, we want to now, we have number of tries before, right? I think number of tries is tracking each game. You attempted a total number of 39 games to complete the 10 games. Okay. So depending on what you want to show, there are different ways to do it. You can have overall number of tries, following the pseudocode again. Increase so before we check whether the person win or won or lost. Win. Nice one. Let's shift those properly. Then else, we only do this else if the person will come into that in a minute. Okay, so we have int overall equals 0, right? Then what was the next thing? Increase overall number of tries. So overall. I'm coming. Okay, we want to track. We can actually have the stuff here depending on. I'm just trying to follow this code, but let's just do what we have here. If increase overall number of tries, so that's the arrangement of this thing is complicated right now because tries here is doing something else. Yeah. So increase overall number of tries, you can see overall equals plus, right? Overall plus is that? Yeah. Then if number of tries, so we have to put this number of tries somewhere. Yeah. So if number of tries, we are using tries now. If tries is greater or equals to 4, we're exiting the loop. Is greater or equals to 4, we're exiting the loop. How do we exit the loop? Throwing equals false, and that is us exiting the loop. Else, right? If it is not, then we want to do this dance here. We want to do the dance, right? Now we'll have an issue here because the way our what are we? Okay, overall is something else. The way our try, we are not reinitializing our try, right? Every time the game is won, sorry, every time the game is played, we're increasing tries. You get that is not we can still do that, but once we start the game again, we want to say tries is now back to remember the same thing we did to true. Once we start a new game, tries is 0. We are keeping, we will still come back to keep the overall try. Yeah, this is overall. We are doing overall for every game that you played. We are always counting. We are always counting. But tries, we are doing that same thing for tries. But once you start a new loop, a new for loop, you know that thing. Once you start a new round, we change the scoreboard. This is the scoreboard for each game. This is the scoreboard for every game. You get? So once a new game starts, we change the scoreboard for each game. That is the only way we can now keep track of that game. So once anybody that scored four goals, bam, we are done. That is, but that's not what we are doing here. But just look at it like we have a scoreboard. Once you score 4 goals, anybody that the first person that scored 4 goals, then we get out of the whole thing. We change, we start again. We change tries to 0, like we change the scoreboard again to 0 because you don't want to start counting from that 4 again for the next game. You want to start from 0. That's why we are doing this. So for 10 rounds, you keep changing the scoreboard for 10 times. So that's it. Let's play it and see if it makes sense. Yeah, I think it makes sense. Does it? Does it? I don't think it does. Let's see. Yeah, it actually does. Overall, this will be overall now. Yeah, it took you 4 tries. 47 tries. So one thing we can do is we can actually split. Let's see the results. Oh yeah, it's actually the same. They did it the same way. So they are just doing it. So the problem here is that we don't even know, we can't actually say where each game stopped. All we knew is that each of the game cannot be more than 4. So if you count this thing now, it cannot be more than it cannot be more than it cannot be more than this is actually more than 40. This is not what we want to do. We're doing something else here, which is wrong. You should actually not enter this well. Now, one other thing, you can see that this is actually more than 40, which should not be more than 40, which means it's actually doing this thing like 5 times. So let's check. Let's try. Let's do something here. I will actually mess with that game. I would just want to show you that this try is going more than 5 times. It's going more than 4 times. It's going 5 times, which means the position of this thing is actually wrong. But I was just trying to follow the this thing, but the position is wrong. Okay, this reset number, that was what I did at the top. I was taking all the resets to the top, but that's it. But the position of this if is wrong. The position of the if is wrong because we would have played the game before. They would have played the game, done the summation before doing this, before now checking. So we need to check before we even play the game at all. One thing you can do is to add that condition here. If tries is greater or equals to 4. No, it's less than. Now it's to be less than. So what we are checking here right now is if throwing. Okay, we won't be needing this again. Actually, I'll explain what I'm doing in a minute. Just hold on. This might work, but I didn't really get my way around this, but 50 tries, that's much. Oh, yeah. Hold on. Could actually is greater. No. Didn't work. A minute. Yeah, this is what we want. So let me just explain what happened here. Now, here, the reason why I have to take this off is because now we've played the game before checking if they've done it more than. So what happened here is this: you played the first one, you dropped 3-4, which is not 12. You play the second one, you drop 5-6, which is not 12. You drop the third one, you did 1-2, which is not 12. That's the third one, right? Is 3 greater than or equals to 4? No, it's not. So we'll continue. Then you dropped the fourth one. Then you're saying it's 4 greater than or equals to. You've dropped it. You've actually played the game before checking. I don't know if you get. You've played the game before checking, so it has been recorded. That's why we are getting something greater than. You should actually not get more than 40, because let's say you lose all the game like we did here. You lost all the game like we did here. Your total should be 40. So, but if you've played the fifth game before checking, then you're in trouble. I can still tweak this thing to work, but I think there's not much time. But all I did was add the condition here. You use this to add, and not really add, and the and command. There is and, there is or. I think we'll get to logical operator sometime soon. But this is a logical operator called and. So all I'm saying is check this value. Is it true? If it's true, also check this value. Is it true? If it's true, then continue. If any of them is false, we cannot continue. So what happened is on the fifth game, he came and checked on the fifth game, which means our tries will be 4. We started from 0. So 0, 1, 2, 3, 4. So on the fifth game, which means our tries is 4. Is 4 less than 4? No, 4 is not less than 4. Then we are out of this game. That is why we actually got something that is correct. Let's see if we can get less than. He's not winning any of the game. He's actually had to win. Yeah, I think he won 1. So we had 39. So I guess he won at the last try. Yeah. Second to the last try. That was why he could get 39. So he didn't play one game here. So that was why we got 39. Yeah, see 37. He also won once. Yeah, he lost all the games here. He won 1. Can't even win 2. Yeah, he won 3. 1, 3. This is 1, this is 2, this is 3. So he only played 38 times. So he missed 2 games. There are a bit of calculations going on here which you can play around and fix, but we are just coding here. So that's that. I don't know. Time has gone and this thing is still a bit much. Let me see. Okay, let's do the last dice, then we can leave this capital to the next class. Let's do the last dice. In the previous exercise, you have added another constraint for losing, only for attempts to throw a double 6. As you may have noticed, it takes a lot less try to complete the 10 games, but you are more likely to lose due to the extra condition. In this final exercise, you are going to increase the chances of winning by adding another constraint, which is if you throw 2 dice with the same value. 2, 3, the English here is a bit complicated, but what they are saying is if you throw the same value twice, if you throw 3 twice, you get an extra. So you dropped your dice, you did 3-3, you get an extra move. You dropped 4-4, you get an extra move. In addition, if you are going to track how many free moves are given, how many games were lost or won, in terms of coding this new rule, this is simply about decreasing the tries value when the dice values are the same. Okay, yeah, that's true. So all we're saying is we're actually keeping track of a lot here, but let's see if we can dumb it down a bit because of time. When you dropped, if dice 1 and dice 2 is the same thing, we just decrease your number of tries. You get as long as we are still in the loop though. Like you don't want to be decreasing values. If the person dropped 6-6, you will never run out of the loop. So if you don't position that thing very well, if the person drops 6-6, you decrease their tries. That means you say, okay, maybe the person has played 3 times before, then the person played 6-6, which the person is supposed to win and start another game. But no, you decrease their tries. Actually, you can do it because you will still leave the game. So that's fine. You can do it anyway. So all you need to do here is if dice 1 equals dice.
Hello.
Yep.
Yeah, I'm not seeing what you're typing. I think you're typing what you're typing is being blocked by this problem, the solution. I think you need to raise it up a bit so we can see what you're typing. We aren't seeing what you're typing.
This is what I'm typing right now.
Okay, I'm seeing it now. I wasn't seeing it before.
Oh, this is what I'm typing. Let me just increase. Yeah, this is what I'm typing. If dice 1 equals dice 2, then decrease tries. So what we are doing is we are just saying if the person drops the same dice twice, drop 3-3. If the person had played 3 times before, we say no, the person has just played 2. I hope you get that logic. I know it's a bit different here, but I think this is just a bit faster. Do you get that logic? The person has played 3 times. Then the person drops the 2 dice and drops 2-2. All we just do is, okay, we know you've played 3 times before, but let's just say you've played 2 instead of 3. Does that make sense? Hello? Hey, can anybody?
We're with you.
Yeah, I want to know if that makes sense because what you have here is different. But if I have to go through this, will take a bit of time, and I don't want to do that. I just want to close it up now. That's why I'm going this route. If you drop the dice, let's say you've played the game 3, you are supposed to play 4 times, right? Now, the condition is telling us that if the person plays the same dice for a particular game, drops double 4, double 3, double 2, double anything, then we reduce their number of tries. So if the person has played 3 times before, once you drop 4-4, we say your tries is now 2, no, not 3. If you drop that 4-4 again, we say, okay, your tries is now 1, not 2. I don't know if that makes sense.
Yes.
Yeah. It's just like saying for that particular game you are playing, we are not checking your tries. Another thing you can do is you can check here. I don't know if we get, okay, yeah, you can actually check here and say if if dice 1 is not equals to dice 2, then you can do this. That is the only time we want to increase this try. So what happens there is if I take this off, where is it? Let me take this off. What happens with this one is the direct opposite. Not really the direct opposite, but if the person drops different dice, then we can add the tries. But if the person drops the same dice, we would not even add. So you play the first game, you drop 3-4, we change your tries to 1. You play the second game, you drop 2-5, we change your tries to 2. You play the third game, you dropped 4-4. We won't touch your tries at all. So you are still, even though you've played 3 games, the board is showing 2. Does that make sense?
Yes.
So at the end of the day, your overall tries might actually be greater than 40 because you might have dropped double number at some point. You can see 44. This guy did not win anything, but I think at some point he might have dropped the same number, probably 4 times. That's why he's having something greater than 40. So at some point he dropped double number and we did not touch his tries at all, but we were still touching the overall count. The overall count is different from each game's count. So what we are doing is, Man U, Chelsea are supposed to play 10 games, right? Then for the first game, Man U scored 4 goals. That's that. On the second game, they scored, on that first game, their tries is 4. Their overall tries is 4. On the second game, they scored 3. Their tries for that game is 3. Their overall is 7. On the third game, they scored 2. Their tries for that game is 2. Their overall is now 9. You get, that's why we are getting much more overall, more than the expected calculation. The expected calculation, which should be 4 multiplied by 30. I don't know if that makes sense. I think I've said some things that are not, but I think you get the gist with what.
Very well.
Yeah. So we'll just stop here. I think we've spent a lot of time. We'll stop here, and next class we can pick up this mathematics here. But you can give it a try. It's more like, okay, it's a bit different. Everything here is actually not, like I was telling some people in class, this is actually not programming. This is just mathematics. How do you deal with board mass? How do you deal with brackets? If you misplace any brackets here, if you put them where you are not supposed to put them. This one, for example, if you put, because you are writing this whole thing like this, you are writing it on the single line. Like there is no space for you to be drawing line and lines and making it fine like this. This is PDF. When it comes to code, everything goes on a single line. So this can easily get complicated if you misplace any of these brackets. That's why I think that's why it is actually bent on us doing this before we go on. So we'll do this in the next. Yeah, you have a question? Hello?
No.
Okay. Does anybody have a question? Any question?
Okay, I don't know if I can ask this question.
Sure. Go ahead.
Okay, it could actually be a feedback you may help us to take back to the instructor, because we want to know if in the mock exam and in the real exam, if we are going to have the pseudocode. If we are not going to have a pseudocode, then will it matter if we write different syntaxes for the code but still achieve the same results? Because if there's no pseudocode, honestly speaking, to achieve this same results in this task, we may have 3 people writing 3 different line of codes but still achieve the same results.
Let me just answer a question. Whether you have pseudo, I will ask him to be sure, but normally programming generally, whether you have pseudocode or you don't have pseudocode, as long as your code works. Now, that is a bit complicated. As long as your code works, you are fine. But your code might work and might not work. That is where pseudocode comes into play. Now, when I say your code might work, when you're dealing with algorithms, there are cases where if you supply a particular function with 2 and 5, it will give you the right answer. If you supply it with 2 and 7, it will give you the wrong answer, depending on the code. That is where you can have issues, because now I will tell you whether you have pseudocode or you don't have pseudocode. As long as you have your code and it works fine, you are good. I don't think that will be applied to us, but I've done some exams like that whereby there are different test cases and different answers. But I think for the scope, I will ask him and I will let you know what he says. But for the scope of this course, whether you use pseudocode or you don't use pseudocode, as long as you run your code and it works, gives you the right answer, you are good to go. But programming generally, there are cases when you run your code against a test case, gives you the answer for a test case, gives you the wrong answer for another test case. I hope you understand that. Hello? That was Shuaib, right?
Yes, Anthony.
But as you said, I will ask him if it matters whether I will follow the pseudocode or not. But I don't think it matters because, like I said, everything is doing here is actually village thing. It's just to add this one line and we are doing the same thing. So although I think he's doing some other things, but basically from the requirement, everything is asking for is just making sure they can play the games if they dropped the same dice. It's just like this, there is no need. So your own code may be more elegant than his own. His own may be more elegant than your own. You get, but as long as you are still getting the same answer. But it's a general rule of thumb to always go with the most elegant code. But for this exam, you should be good. Any other question? Okay.
Tony,
Okay.
I wanted to ask these tasks, that so say task 1, do this task 2, do this task 3, do this. Will it be like that on the exam? I'm not sure you know because you've not taken his exam, but I would like if you'd ask him. Do you understand?
I'm trying to see if I have seen this paper. I will check. I will check with him. I will also check if I'll check if I've seen this paper before. I will actually. He might actually not answer that, but that's the good thing with the mock that we'll be taking. We'll actually see what it looks like, but it will actually be progressive. It might not be like create lab 3_1. You should know how to do that yourself. There might not be create a main function inside. You should know how to do that yourself. But at the end of the day, it will still be progressive. Get the input from the user, then use the input to calculate the area of a circle. Could be as simple as that, right? But I don't think there will be things like this number 1. This number 1 is just for us to know what we are doing. But it's going to be progressive. But once we do the mock, we have much more idea. Like you said, the mock is not really a big deal. It's just for us to know. So whether you understand or whether you do the mock very well, you don't do the mock very well, is a plus because now you know what you're expecting.
Yes.
Yeah. Do we have any other question?
Yeah, so I want to ask something.
Okay.
Yeah, my question is, I think during the fourth question, they were told to constrain it so that we have just 4 tries.
Yeah.
We have just 4 tries. But when you ran it and the result came out, I wasn't up to 48 tries or 49 tries. So it really got me lost at that point.
We are getting these values, right? We are getting 47. We are getting right.
Yes.
That was what I explained earlier. We are playing. There are 10 rounds. Get there. Yeah, there are 10 rounds. But for each of the rounds, you will play 4 times. The maximum you actually play 40 times.
Okay.
Yeah.
10 rounds.
You can play is 40. That is it. But It's just like the game of football like I've been using. You can score as goals as you want, but we want, okay, it's just like Premier League. In a season, every team has the number of games they will play.
Yes.
So let's say the number of games every team will play in a season is 10. That is the first condition. But in each game, they can score up to 4 goals, which means at the end of the day, no team can score more than 40 goals. Yeah, you get the idea now.
Okay, I don't know.
They are playing 10 times. They have 10 rounds, but they can go to somebody's goal post four times in each of those 10 games.
Okay. Yeah, makes more sense. Thank you. I'll look at it more.
That's why this is a loop. This 4 is a loop itself. This Y is a loop. So you are looping inside another loop. So the small loop here is saying they should play 4 times. Then there is another loop saying that 4 times they can play 4 times 10 times. So you play 4, you play 4, you play another 4, you play another 4 in 10 places. Makes 40.
40. Okay. Makes sense now. Thank you.
Yeah, no worries. Do you have any other question? Okay. Good evening, everybody. Take care of yourself. Have a good weekend. Bye.
Bye. Thank you.